Hello, everyone. Welcome to today's webinar, Why Outdated Perceptions Are Holding You Back, the Evolution and Applications of Ethanol, CO2, CXE, and Multi-Solvent Extraction. My name is Eric Sandy, and I'm the digital editor of Cannabis Business Times. In today's webinar, you will discover how using solvents like ethanol and CO2 together can give you dramatically better results in your extraction operations. You will learn why a novel application of this old idea is the key to unlocking new product innovations, simplifying your processes, and maybe even saving your business. And you'll go back to your business this week knowing and using the word co-solvency. So to that end, we are pleased to host a discussion among John McKay, PhD, of Synergistic Technologies Associates, Mark Webb, the Aroma Science Guy, as well as Jason Larond and Nathan Houghton of Vitalis. Before we get going into this dynamic and wide-ranging conversation, I just want to make a few quick notes. You're going to see at the bottom of your screen the Q&A button. If you click that, that'll open the Q&A box. So please feel free to type your questions in as we move through the presentation, and we will get to as many as possible at the end of the event. Also, just know that we are recording today's webinar, and we're going to send a copy of the video to all registrants via email in the coming days. And with that, I'm very pleased to pass the mic to Jason Larond.
Thanks, Eric. As he had said, today you'll discover how using solvents like ethanol and CO2 together can give you dramatically better results in your extraction operations. The future looks better when solvents work together instead of in competition. It's a new era in extractions. Nathan?
Yeah, so just to give you a quick run through of what this webinar format's going to look like, we're going to first discuss some of the perceptions of CO2 traditionally that have been held in the space. Also, how traditional CO2 extraction has been done, and how this equipment and this application with co-solvency moving forward, how it's done differently. And we'll talk about that and a little bit about the technology. And then we'll have some time for John and Mark to give their take on co-solvency in this space, and especially its relevance within the hemp and cannabis space, and also maybe a little bit outside the space as well. And then we'll have time at the end for a Q&A to have some questions answered. So we're going to start off first by talking about some of these perceptions that have existed associated with CO2 extraction. One of the most common that we often hear is that CO2 extraction is slow when compared to other methodologies, and extractions may have taken 4 to 6 hours in some equipment when supercritical extractions or subcritical extractions, perhaps longer. And that's kind of evolved and changed by introducing a small amount of ethanol into the extraction. CO2 is expensive is another one. The capital equipment and upfront costs associated with the equipment historically has been viewed as expensive when compared to other solvents. But that has changed, especially when it comes into throughputs. Throughputs have been one of the pinch points in CO2 extraction equipment historically, and by introducing a small amount of ethanol in line, we're able to greatly increase the throughput of the equipment and the same amount of floor space. Another one is that if you add ethanol, it might not be pure and may pull chlorophyll, and that all depends on the pressures and temperatures that you operate at. And lastly, that ethanol requires a C1D2 classification space, and we've actually, with our equipment, this technology, we've integrated that within the equipment itself. And as far as how CO2 extraction has been traditionally done in the past, typically high pressures and temperatures, supercritical parameters, longer extraction times with lower throughputs that I did mention. The necessity to decarb before extraction, which is not necessary in this equipment when using co-solvent. And typically and traditionally, there's been a high wax content in the extraction, the tendency to pull fats and waxes when operating at supercritical parameters, and large amounts of post-extraction process refinement, winterization, filtration, the associated wax and fat content that can be extracted in those. And when we introduce this technology, we're actually able to pull much less of that. And also that terpenes traditionally could be extracted in environments that involve high temperatures. That could be in a vacuum oven, that could be in steam distillation. and that could subject terpenes to thermal degradation. Some of the other limitations we've seen is in the operational parameters and abilities of extraction equipment. That could be the pressures that they operate at and also the temperatures, their operational ranges. So Vitalis's equipment does have a wide range of temperatures and pressures that it can operate at. And what we found is that actually introducing ethanol allows us to run at a much lower pressure and get a much higher extraction efficiency. And one of the greatest advantages that we see with introducing this co-solvent technology is the ability to have operational flexibility built into one system. So traditionally, in some larger operations especially, we may have seen CO2 line running parallel next to a ethanol extraction line. This equipment, this technology does give operators an option of having one piece of equipment do what essentially two separate extraction lines would have traditionally done. And that has some implications as far as lower startup costs, lower operational costs. Heating is a very expensive operational cost when it comes to ethanol extraction. And by introducing a small fraction versus a full ethanol extraction line, the amount of energy and heat for recovery of solvent is much lower because we're dealing with a fraction of the solvent that we would be in that full line. That also equates to a lower cost of gram of production, which especially in the current environment of compressed pricing, and we're seeing some pressures there, market pressures, that the ability to produce at a low cost per gram is extremely important. This equipment allows you to do that and reduce labor costs, operational costs with energy, and also being mindful of the amount of floor space that you actually take up in the facility. Now, the CapEx, if we're doing a true comparison between CO2 extraction with co-solvent technology versus a full ethanol extraction line, which you're actually able to use this equipment in place of that, when you look at the overall costs and take into account your facility build-outs with your C1, D2 space and classification, the costs associated with that, the different components in an ethanol extraction line, the comparison costs actually are pretty comparable, if not less expensive, to do CO2 with co-solvent and be able to manage and process a similar amount of biomass all the way through. And also, one of the main differences in this technology and using it is that whereas in the past, to reach some of those throughput numbers that make sense, you may have decarbed pre-extraction to be able to extract more material in less amount of time. With this technology, by decarbing after, you leave the door open for THCA products, THC products if you want to decarb before. The thing is, you don't have to. It's not a requirement, it's optional. And that gives you the flexibility in the products that you're going to make, as well as how you're going to go about producing them. And there are numerous applications outside of hemp and cannabis, and maybe give Mark and John just a moment here just to mention a few of those.
Yeah, thanks, Nate. Well, there's a myriad of other botanicals that can be extracted using co-solvent CO2. Some of the favourites I like to talk about: German chamomile, vanilla, astaxanthin, which is a very lucrative bioceutical. So a ketocarotenoid, so it's what's found in krill oil. Marigold extract or calendula extract, rosemary antioxidant extracts, and then there's a whole pile of lipid extracts that are used as AIs in the cosmetics industry as well. So it's having that co-solvent capacity really opens the door for when you've got downtime on the rig to look at other crops and to diversify. John, you got any comments?
I think some of the ones that we look at and overlook some, and that's the common one as far as hops. And industry uses this at enormous rate and well documented. The other ones are, decaffeination of coffee and tea, and then also, of course, nicotine from tobacco. So each one of these has been used and used successfully with CO2, but also the necessary need for a co-solvent in some of those respects. It's water from coffee grounds. And because the coffee itself, after it's been used, the coffee ground has exceptional number of other botanical products that can be used in the industry.
Yeah, thanks for the input on some other applications of this technology outside the industry. Another thing to note is that there's a big difference in what the output is outside of the system when you compare it to a monosolvent extraction. Jay, I don't know if you're going to pull up that picture. Traditionally, you could see what looks like perhaps a subcritical or supercritical extraction on the left in that before photo. Kind of that peanut buttery type texture of output. Any operator in a lab, potentially has broken a few spatulas working with that in the collection vessel. That sort of struggling with the viscosity is changed. If you look at the right, you've got what looks much more like mycelia ethanol in extract, already homogenized, coming out, flowing out of the machine instead of potentially clogging up the output or perhaps being frozen. It's much easier to work with, and the fact that you're working with an extract that flows and also has ethanol in it has some ramifications for the system being cleaner and also requiring less maintenance, but also the workability and the reduced labor and actually transferring, pouring, working with that extract in the downstream processes. So that's something to be grateful for in this equipment, is that that also contributes to the lowered cost when you look at it versus monosolvent only extraction.
That's right, Nathan. If you look at these two videos of what would be a traditional monosolvent CO2 based extraction on the left and a co-solvent extraction on the right, every lab is going to be different, but to split it down the middle, it'd be very common for most monosolvent extractions to have on the order of 50% waxes, which need to be removed in post-processing. And that can be done in a number of different ways, but traditional ethanolic winterization is the most common method. And all of these downstream processes are more humans, more pieces of equipment, more steps, transfer losses, time in the freezer, yield losses. And with co-solvent extractions, we're able to do some really interesting things. This is not a new idea. As Mark and John can attest, this technology and the use of co-solvents added to CO2 as part of an extraction operation has been around for 40 years. But what has traditionally been done is just add ethanol to an existing supercritical CO2 process. If you look at the CO2 process itself, how do we make the process faster? Well, we turn up the pressure and we turn up the temperature. But when you add ethanol to that environment, you end up really just extracting everything you were before and more, just faster. And so you create a pretty ugly looking oil. And Vitalis's claim to fame has always been since the beginning that we're able to operate sustained sub-zero, subcritical liquid parameters, very low pressure extractions, which for the cannabis industry wasn't particularly desirable unless it was a terpene operation and you're looking to extract some of those lighter volatiles. But the magic is if we take the combination of those low pressure, low temperature, sub-zero, subcritical extraction parameters and add ethanol to it, we end up with this beautiful, easy to work with extracts that may have on the order of 3 to 5% waxes. So there's a very small amount of post-processing required. And the ethanol you probably would have added as part of your ethanolic winterization process downstream is already in your extract. So now you've removed the homogenization step downstream. You have a homogenized process with a very small amount of ethanol, far less than you typically would have in an ethanolic winterization process. And you can basically skip straight to effectively a quick freeze, a simple single pass filtration in most cases, and then a solvent recovery. And you are making a very, very high quality extract in a fifth of the time, using far less labor, equipment, consumables, and work. And as Nathan had mentioned earlier, in today's market, every penny it costs you to create every gram that you make is the make or break for your business. Gone are the days of $30,000 kilos. And so when we're using equipment and processes that were designed around a $30,000 a kilo output in a market where in a lot of markets you're sometimes getting 2,500, less than 1,000 in some markets, every penny it costs to make every one of those grams is that much more important.
Absolutely.
Mark or John, anything to add on that?
Jason, look, I've always believed in work smarter, not harder. And when I first started looking at the cannabis industry, I was quite gobsmacked at the way they were utilizing supercritical technology. And it's been done in other botanicals for a very long time as well. And it's almost akin to the absolute and oleo resin industries where they were making flower absolutes, where they would use a hydrocarbon solvent to extract the flowers. Then they would they would chill it, drop out the waxes. Sound a bit familiar here? And then they would redisperse the material once they vacuumed off the ether with ethanol and then have to clean it up. So I've always looked at those sort of processes as being a bit archaic. And to me, CO2 has been tunable. And that's the beauty of this sort of co-solvency and also working subcritically. You don't get up to those temperatures and pressures that will extract as much color and as much of the wax. And for some botanicals, those waxes and colors are important, but not in the case of hemp or cannabis. You don't want them there. They're byproducts that gum up your downstream products that you want to make. So yes, this is a much better technology in my opinion. John, any comments?
I think one of the things that happens as you're moving to the ethanol process is that we don't see the amount of oil that accumulates inside the walls of the capillary tubing. So many times that process is coating along the way, and then you're trying to get rid of it with ethanol in between runs. So I think it also takes the advantage of being able to do clean in place, which is essential as you move through the process. So you have something in line already that allows you to automate your clean in place. And that's a second advantage besides the extraction, is making sure you're not extracting material from the previous run or collecting it from the previous run rather than each individual run, especially if you're changing varieties of material that you don't want to be bringing in one variety and then bringing in the next variety and meshing them up.
Yeah, we see that live in the field, John, that our customers that are deploying this technology have much longer intervals between maintenance cycles. Their cleaning is a much simpler process. And as we all know, and I hope everybody listening knows, CO2 is an incredible solvent. And so it does a really good job of cleaning the system. And when you add a little bit of ethanol to that CO2, it does a really good job of cleaning the system. And any residuals that are still left on tubing or cyclone or extraction walls are very simple to clean. You don't have that thick waxy paste to clean up. It's just a thin film oil, and it cleans up very, very simply.
And just to explain a little bit about the process and how our co-solvent system operates, you're still able to do monosolvent extraction in this system. And that's very important to point out. When you're extracting terpenes at the beginning, you're able to do that with just a pure CO2 extraction. And then you're able to go right into a cannabinoid extraction utilizing the co-solvent technology. And that's after that major cannabinoid pull is done. And what we're seeing is, on average, it might be maybe an hour plus or minus, depending on the size of the vessel. But when you compare an hour extraction and what's, quote unquote, been a CO2 extraction system, and still be able to get above 90% of what you're targeting within an hour, those are results that are 400 or 500% faster than traditional monosolvent extraction only, and that's huge. And then after the cannabinoid extraction with the co-solvent, we'll go back through and we'll do a CO2 only extraction just to purge any residual ethanol from the biomass. So what that means for you and your operation is that there's no additional step needed for additional ethanol remediation. It's the majority has been taken out. It's within acceptable ranges to be disposed of. Jason, do you want to add something to that?
Yeah, and that was a real stroke of genius on the engineer's part. When we kind of look at the extraction methods to begin with, typically in an ethanol-based extraction, you end up with a depleted material that's had its cannabinoids removed, but now it's got a fairly high content of ethanol, and particularly in jurisdictions where incineration of waste is required or mandated, that can get really exciting when you have a high ethanol content waste material that sometimes has to be treated as a hazardous waste, or there's a significant cost to moving and storing it. And so there's all kinds of remediation processes that need to be deployed in an ethanolic-based extraction process, whether it be steam distillation to remove residual ethanol. I've seen as old school as laying ethanol soaked biomass out on the floor to let it dry out. There's all kinds of really interesting processes that need to be done to make that product that you've now extracted easy to manage. And like Nathan had mentioned, you still run monosolvent CO2 for the first few minutes of the extraction operation. So you're doing CO2 only subcritical cold liquid terpene extractions. We can make that CO2 so weak as a solvent that it really only has an ability to extract those light volatiles. End up with a real beautiful terpene fraction. We then inject ethanol for the body of the extraction to pull out the cannabinoids, and then cease the ethanol injection, but continue to run CO2 for a few more minutes. And what that CO2 will do is now extract the residual ethanol in the plant material. And generally, we're seeing plant material coming out at below 1,000 parts per million of residual ethanol. So you get a really great recovery of your solvent that is probably one of your most expensive consumables. But also you have this plant material that's perfectly dry, just like a CO2 extract product that you can cart away as a standard extraction waste.
Yeah, that's a great point, especially taking that into account, the high recovery rate of ethanol and the residual biomass, and combine that with the fact that you're using a fifth or potentially a tenth, depending on the flow rate. When we're talking about 1 to 5% injection rates, you take those two together, and ethanol certainly isn't getting any cheaper in the marketplace. So being able to capture as much that you can and recover it is huge, and plays into cost of operation. It can be a huge expense. And I think that also plays into one of the other advantages of this technology when we look at moving forward in the extraction industry, and it being a green industry and being sustainable. We're trying to lower our impact or our footprint on the environment and still operate and be profitable. And this technology specifically, when you have the ability to use less ethanol and use CO2, which is a neutral gas, or at least what the foundation of the emissions are based on, is CO2 gas itself. When you're able to combine these two technologies, you can really lower the amount of ethanol you're using. And an interesting thing to point out on that sustainability side with this equipment is that in this next generation of equipment, instead of using HFCs or CFCs for the internal heating and cooling, we're using CO2 as a natural refrigerant and eliminating completely HFCs and CFCs from our offerings, which I think is huge and is a great step forward as governments begin to phase out these more restricted and I guess gases that have a greater effect on the ozone layer or greenhouse effect. So that's an important thing to point out.
Yeah, that's a good point, Nathan. And also too, I mean, the overall energy usage of your system from my looking at it is significantly less. So, it is green solvent chemistry because of the recovery of all that ethanol. You're not wasting it, it's being recycled. Using CO2 refrigeration, which has been around again for quite a while. It's one of those industrial applications similar to dry cleaning impregnation of dyes and chromatography and the like that have been around, as well as the stuff John mentioned before. It really does make a huge impact, and regulators look favourably on this type of moving away from high energy systems. This is why CO2 supercritical was developed in the United States in the 70s, was to try and get away from hydrocarbon solvents, to try and get away from the high cost of steam distillation, because there's so much energy put into having to heat stuff up. There's a huge amount of energy. I think from memory, extraction of aromatics in the US, it's about 5% of your total energy budget, which is massive. So, when you're applying smarter technology, it really does help. And with the cost of energy these days, here in Australia, our energy costs are going up and up. So industries are looking at how do we lower our energy costs, not increase them. So this is a great system from that perspective.
So Mark and John, just like to open it up a little bit to, do you see any applications or any benefits that haven't been mentioned as of yet, things to note as kind of industry experts here, anything to mention within the hemp and cannabis space where you really see this being a benefit or being an advantage that you'd like to share?
Well, as you've already shown, your extract is pretty much clean. You've very minimal post-processing to then move it into your various dose forms, your edibles, your smokables, your vape cartridges, etc., etc. For medicinal applications and also food and beverage applications, this is much easier to work with. It's work smarter, not harder, has always been one of my adjuncts and my catch calls, and reducing labour costs is also another major importance. Again, here in Australia, our labour costs are huge, and so we've got to try and minimise it. So I see this as being able to remove so many manual steps, so many steps that require additional equipment, additional space, and additional labour. It's a win-win. John, your thoughts?
There's 3 boundaries that I typically put up. One is speed, one is selectivity, and the other one is scale. And if I use those on the footprint of a triangle, then that's how you would monitor the process that you're using. And for me, it's process centric. And so it's more of the ingredients that you're needing to make into whatever your final product is. So as Mark brought up, sometimes you're wanting to have some of the waxes in there because you're going to be making yourself a lotion or something that allows you to use those other compounds that also have therapeutic anti-inflammatory characteristics that have been well known in the industry with aromatics. So if I'm making something that I'm going to go on my hand and I make it so pure and then add Crisco afterwards, that doesn't seem like a great idea. And I think that when you're working through selectivity and speed, now you have the opportunity of tuning with one instrument around that triangle. So you're not just having a point and you're at room temperature ethanol and taking everything off. That's very, very fast. There's no selectivity. But you're not getting, you're not getting the selectivity, but you're getting speed and scale. And so I think that this allows someone to move around that triangle. I would say that the point on my triangle versus the point of my discussion, the point of my triangle onto the pyramid is spin. And I make that into a $sign with an S. So now you've got your CapEx and you have your constant manufacturing. So when you're looking at each of those, it gives you the opportunity to not only maximize your spend on how you're using your fund to move around that triangle. So the more flexibility you have. So if I've got a hybrid bike, that's much better than a single speed bike. It allows me to do mountain biking, allows me to change the tires, it allows me to be on the road. And so it gives you those capabilities. And so when you're looking at that, that is the advantage of having more flexibility and more options.
I think that's a great point. Go ahead, Jason.
Thanks, John. Yeah. So one of the things that often comes up, a pretty common question, is questions regarding compliance. So, you know, we're really dealing with two really big compliance challenges whenever we deal with co-solvent based extraction. If you're dealing with ethanol, generally it's volumes of ethanol that you're allowed to have on site at any given time, and how are you handling it, how are you containing it, and how are you mitigating risk. In CO2, you're managing pressure. In this particular application, we deal with both. And so, first things first, Vitalis is a manufacturer or certified manufacturer of pressure equipment based up here in Kelowna, British Columbia, Canada. We can do our own ASME and CSA CRN stamped pressure vessels in-house. We don't have to farm any of that out. We also have the certifications required to manufacture vessels to PEDCE for Europe, AOS NC 1200 for Australia and New Zealand. And the real advantage of being able to have all of those under one roof is that we have many customers that are multinational customers. They've got equipment operating in Canada and the US and Europe and Australia and New Zealand. And what's really great for them is that they can basically operate one recipe by operating the same piece of equipment. They don't have to have a different piece of equipment that's compliant in each different jurisdiction and then try to get the recipes to work on different pieces of equipment. When it comes to ethanol, what's really interesting about this particular product is we really went in designing this product from day one saying the vast majority of these pieces of equipment are going to get added to existing CO2 equipment who our customers are already in the field, or customers who have an existing facility would like to purchase our equipment because of its advantage that it brings to the market. But none of them, it's going to be a non-starter if there is a massive facility retrofit in order to make that piece of equipment legal and compliant to roll through the door. And so the first thing we really figured out was, how do we make this piece of equipment go into an existing room that already has a CO2 machine equipment operating where we just plug it in and turn it on? And how we do that is we completely shroud and enclose the unit. And we pull a negative pressure on the chassis. We've effectively built a Class 1 Division 2 box around the unit itself. And that allows us to keep negative pressure and the LFL below 25%. So we already have a third-party peer review. All of that documentation comes with the equipment, and so it satisfies the engineers or inspectors requirements in the jurisdictions where we've installed this. And you know, this is not a one of or a two of or a new technology. We've developed this equipment and had it operational in the field for the last 3 or 4 years. Some of the largest cannabis companies in the world operating in Canada and the US have this deployed fleet-wide, standardizing their entire product lines on using this process to make the products that I'm sure many of you consume today and don't even know it, that it's coming out of this equipment right now.
Jay, did you want to talk a little bit about one of those operations in Canada?
Yeah, so the first customer to take delivery of this was a large processor of outdoor cannabis called Christina Lake Cannabis, located in southeastern British Columbia. They've got 32 acres of outdoor cultivation, pulled down about 33,000 kilos of outdoor product. And the entire product was, well, I mean, they ran an R200 running monosolvent, and there was a concern that they would take down so much product. Their harvest was so large, there was a concern that they may not be able to crush through their entire harvest using their instruments. And prior to co-solvent, really the only option was, and this is really the question that most people need to do, if they need to double throughput, then you just buy double the pieces of equipment. And with co-solvent being added to their existing operation, they were able to process through that entire harvest and have a number of months of idle capacity that they're able to satisfy by purchasing additional product that was available on the market and further contribute to their bottom line, and now supply bulk extracts and distillates to most of the Canadian market. Many of the largest Canadian cannabis companies are actually using Christina Lake extract in their consumer-facing products, and all of it is being processed on co-solvent.
Yeah, it's a huge impact in going from a place of being at capacity to a place where you're looking to source biomass to meet your capacity. That's a huge change overnight. And you can see you've got a video that's a R200 with our standalone CIS system. That's available to existing Gen 1 system owners, so they can add that technology and be able to integrate it with the current existing Vitalis systems.
Yeah, it's a very compact piece of equipment. I mean, obviously our extraction equipment can range anywhere from 10 liters to thousands of liters if a customer should so choose. But the co-solvent unit itself only takes up about 9 square feet of square foot space. It rolls through a standard door. Actually, any Vitalis that was built after serial number 2 actually has a co-solvent injection port built right into it, and all of the automation and hardware required for the 2 pieces of equipment after serial number 30 are actually built into the unit already. We've actually known that this was a product that we wanted to bring to market. It just took a global pandemic and a few months of idle time to sit down and actually do it, and this is what came out of that effort. So having almost 200 pieces of equipment, commercial and industrial scale pieces of equipment operating on 5 continents now around the world, almost 4/5 of them are actually ready to take delivery of a co-solvent. And it's as simple as rolling it through the door, plugging it into air and power, plug it into the Vitalis, and we're usually making co-solvent extract on the second day.
We've got a couple questions rolling in. Do we want to hold off on the Q&A, or do we have any? Mark or John, do you have anything that you'd like to bring up at this point? We have a few minutes before we roll into that phase.
I decided to let my older brother talk first.
Sorry, you're calling me the older brother. I'm only 61, mate. I know you're significantly older than me. Look, do we have data on lowering the much lower fats and waxes with co-solvent? I'm sure the guys have got that in-house to be able to give that to you, but I've got research papers on that. Can you identify and discuss waste disposal, recycling, and how service providers are identified? Well, I think you've already touched on that one, so I don't know that we need to add on that. Or do you have service providers you want to talk about?
I think that's very geography specific. So everyone's going to have different requirements needed depending on what their local jurisdiction is. So I think that's going to be specific on where you're operating, because every state is different. There's that lack of uniform compliance currently. So that's going to vary.
Yeah, there's jurisdictions that will let you just blend it with rock wool and bury it in the backyard. There's others that will require you to have a licensed contractor take it away and have it be incinerated. It really is geography dependent.
Down here in Australia, it's all any medicinal cannabis post extract has to be high temperature incinerated.
Sure.
It would be so wonderful to compost it and put it back into a field, but then once it's completely stripped, we're not allowed to do that. So some of the people that I work with, we're looking at doing activated biochar from it as a possible source of revenue as well.
Very interesting.
And we just had a question come in kind of regarding the throughputs of our systems and the technology. And Jason mentioned the vessel sizes as small as 10 liters. And I think it's probably helpful to give you guys some information on typical throughputs we kind of see in our offerings. And the question that came in is the change of technology worth it for a small producer? And by small, they say 14 to 15 kilos per day. For some, that may be small. For others, that may be large. But I guess it depends on what technology you're currently operating and how you're currently operating would be my first question to kind of make that evaluation, is look at your current system and what kind of efficiencies and throughputs you're getting to be able to kind of have some more information to make that analysis. Now, our systems do go down to our smallest size, which Jason mentioned is a 10-liter system. And in 24-hour period, you could see up to potentially a 50 kilo a day throughput in 24 hours. So that smaller offering, which does come in a couple different configurations of vessel sizing and 10 and 20 liters, is a good size for what you might call a craft operation, or up to or under 100 pounds of processing per day, or 50 pounds per day or up to 50 kilos at max capacity. So I think
Yeah,
we do have.
it's not an uncommon question to kind of look at a technology like this and then look at it as a way to accelerate an operation. Great, I can buy this piece of equipment and now it becomes 5 times faster. But for smaller operations, you got to think about the other side of the equation as being a real advantage to you. If you wanted to process 15 kilos a day, you could probably do that on like maybe a 10 or 20 liter piece of equipment running monosolvent, running 24 hours a day. Maybe you buy yourself a 40 liter extractor or a twin vessel machine, for a couple $100,000 more, maybe able to crush that down into 8 hours. But now you could look at a very small piece of equipment, a little 10 liter, running 8 hours a day, Monday to Friday, and being able to go through that, easily. So technology like this allows smaller operators or large operators to really look at their equipment and say, wow, I can buy a piece of equipment that's a third of the size, significantly less cost, and be able to process through that same amount of material that traditionally I would have to buy a larger piece of equipment to be able to process.
Yeah, and have to run that larger piece of equipment 24 hours a day versus, as you mentioned, one shift, which is huge.
Yeah. Do we have any more questions?
Yeah, there was a question. There's a question about the ethanol being waterlogged after an extraction from the moisture in the biomass. Well, you don't get water carryover with subcritical CO2. The water actually gets left behind, and there's so little ethanol in there anyway. It's not going to pick up too much of the water out of the biomass to start with. If you're using dry biomass, which I'm making the assumption that you guys mostly do anyway, it's going to be minimal, and you can dry the ethanol fairly quickly and easily anyway in the recycling process. So, Jason?
Yeah, many of our customers are using the same. So after ethanol is removed from the extracts in post-process, many of our customers are using that ethanol again and again. So really it just goes right back into the feed tank that is feeding the co-solvent for the subsequent extraction operation. So really the only limitation for almost any operation is what do you consider an acceptable batch size or lot size? Because obviously for quality control purposes, you wouldn't want to have ethanol recovered from one extraction to be in a different lot. And so no, many of our customers are doing it, and no, it doesn't. It isn't a problem. As Mark had said, subcritical extraction, and I'm not sure if everyone has kind of heard of that term. Supercritical extraction is just kind of it's just generally regarded as being the CO2 method. Very large pressure and temperature. This particular process never operates supercritically. We're always operating in a cold liquid state.
And liquid CO2 does not pull water. It doesn't have an affinity for water, unlike supercritical. So you don't get it contaminated, even if the biomass is slightly more damp than traditionally used. So I've had experience with liquid CO2s for 25 years and from various other industries, and I could never understand why more wasn't being done in the cannabis space, frankly, when I first approached it. And now you guys are doing it, and it makes perfectly good sense. It's a very smart way of getting what you want out of the plant, sure, without taking all the other rubbish that you don't want.
Now, Mark or John, this actually might do with a more of a technical explanation. But can you explain why it's faster in more detail to use a co-solvent versus using CO2?
John's going to be the mathematical genius to tell you why the coefficients of extraction and thermodynamics work, but from a research perspective and from going over the various papers I reviewed prior to this webinar, in many cases the increase in speed, it's pretty much universal across most plant material, and it's significant. We're talking dropping times by half or less, half or more. the problem with CO2 is it's a very non-polar solvent in its supercritical state, and many of the cannabinoids are polar. They have an affinity to polar solvents, which is why ethanol works so well. Well, by bringing in liquid CO2 with the ethanol, you're combining the best of both worlds there. The liquid CO2 is a non-polar solvent. Adding the ethanol basically entrains it and helps to tease out all those compounds from the plant at a much, much higher rate. It's got to do with surface tension, I think, from memory. John, comments?
Yeah, there's a lot of different parameters that work through that. The easiest statement is like dissolves like,
yep,
which is what every chemist is trained on. So CO2 in the subcritical and supercritical is more like hexane. Its polarity is similar to hexane. And if you were to put hexane on a plant and then trying to figure out how much is coming off, there's going to be a certain amount of time period that goes with that. When you have a more polar solvent, so polar just means that you have more negative charge and positive charge, so ethanol certainly fits into that, then you're going to elute more compounds. The term is log D or log P. Where it looks at the polarity of a compound. You can also note with just a small amount of the ethanol, you're going to break open that trichome wall. Where with CO2, with its high diffusivity, it will go into that wall, grab the compounds and come back out. With ethanol, you're bursting that wall so that they're more readily available. And so you have a couple things that you have. You have thermodynamics in your favor, and you have mass transfer in your favor, because once you take out those compounds, it has to move down the stream. As I like to say, a dead fish in a fast moving stream looks like it's making progress. But when you actually have something that's going through a process, then it's dissolved in that water stream. Other times things are just being carried on. So as people like to say, they say, well, a house isn't soluble in water, but it doesn't stop it from a hurricane moving down the coast. So with the ethanol, you're actually dissolving the trichome, you're getting the compounds out, you're getting more of those compounds out, but you can selectively regulate that by the amount of ethanol. So you can have CO2 and a 1%, CO2 plus a 2%. So each one of those will expand, expand, expand. So you're taking your bicycle and you're going through 5th gear, 6th gear, 7th gear, 8th gear, 9th gear. So you can increase that speed. So the ballpark is like dissolves like, so it's going to be faster, just in the fact that your thermodynamics is working in your favor. The mass transfer isn't changing, but the thermodynamics is allowing more things to be soluble.
Thanks, John. And on that thread, and this can be a discussion that we can have offline with any of the participants or in another discussion, but the same is true really for any co-solvent. For the nature of the conversation that we're having today, ethanol is a fantastic co-solvent for the targeting of cannabinoids. But if we were to be processing any kind of input material, any botanical, and I'm after polyphenols or alkaloids, all of those things are soluble in CO2 plus something else. And really the key is how much of and of what added to that CO2 stream will effectively extract that without going too far. Like John had mentioned, we're going to add 1% CO2, 1% co-solvent to the CO2 stream or 2, but you can't go too far. I can add too much, and then that environment can start co-extracting things like sugars or chlorophyll. We've put a lot of time, effort, and R&D in determining exactly what that recipe is to get you that really great speed without diminishing quality, kind of flipping over on the other side of the curve. But when our equipment is used for the processing of things for flavonoids or polyphenols for mouthfeel in the beer industry, or you name it, It's CO2 plus something else. What the co-solvent doesn't necessarily have to be ethanol, but for this particular application, that's what we use.
And having them be miscible.
Huh? Yeah, exactly.
So if you add too much ethanol, now you got a biphase.
Hmm.
And so having that miscibility is critical as a uniform solvent.
And other co-solvents like that are commonly used are things like ethyl acetate. Methanol is used as well, although it has its own problems of being toxic, so that's why we tend to use ethanol.
Mm-hmm.
What else? Oh, even water can be used as a co-solvent in some applications, but not in this system because it's subcritical. But in supercritical, there have been water's been used. John, can you think of any other chemicals that they've readily used? I know I've seen a lot of papers on ethyl acetate as being in methanol and ethanol, but anything else come to mind?
Well, the ethyl acetate even versus hexane has been used. You'll get other compounds that come out. They're so close in flex in solubility, but they're very different as far as the polyphosphates versus just some other alkaloids that come out. You will get more out. So a gradient of those will give you a step gradient of compounds that come out.
Yeah, and we can use water. I mean, the fact that the purpose of this discussion is primarily around the extraction of cannabinoids, extracting from cannabis or hemp material, and so using ethanol. But our equipment certainly can do co-solvent injection in supercritical parameters. It's just not the best way to do it as it relates to cannabis. So as it relates to cannabis, we operate basically at the floor of as cold and as slow as the machine can operate, because that's what gives you the best yield and the highest quality product in the shortest period of time. But if a customer wanted to extract from some bark or seed or berry or you name it, it really ends up being CO2 plus something, and then optimal pressure and temperature parameters to extract that. Because ultimately that's what we're trying to get at whenever we're doing an R&D project with a customer, or we've already done the R&D to satisfy our own curiosity and we're approaching a new industry. It's hey, look at all this work that we put in for the last couple of months. We've got the recipe book. If you run it at this pressure, this temperature, with this injection rate of this solvent, then you have the best quality product in the shortest period of time. How many would you like?
And that's the tunability of CO2 rigs. It's 21st century technology versus 5th century.
And especially in this system, retaining the tunability while picking up some of the efficiency properties of an ethanol extraction. We have a question that came in asking just for a little bit of clarification on the workflow and the system. So I'll just run through that again. They ask just if we can clarify the workflow, mentioning that we do start by loading dried biomass into the system and doing a monosolvent terpene extraction with subcritical parameters. That's how it starts. The biomass doesn't need to come back out or doesn't need to go anywhere. All of that, the terpene extraction, then cannabinoid extraction happens within the extraction vessel. So after that terpene extraction is complete, we'll go into a subcritical CO2 for a few moments as it transitions into adding the co-solvent for the bulk cannabinoid extraction. And as I mentioned earlier, depending on the vessel size, that could on average be anywhere from 45 minutes to an hour and 15 minutes long, depending on how large it is. And after that's complete, it goes into kind of the purge cycle of back to pure monosolvent CO2 to pull out any residual cannabinoids and ethanol to close out. And then of course you would follow that with whatever method of solvent recovery or decarb stage if you want to decarb as well post extraction in a separate piece of equipment. And we do actually have another piece of equipment that can help with some of those downstream processes as well.
Yeah, so the terpenes are never subjected to ethanol. They're extracted using CO2 only. And then we extract the cannabinoids. So you have one lot of input material and two completely separate outputs out of the machine. And then we recover any residual CO2 still latent in the plant material using CO2 so that we get a high recovery of our consumable.
Yeah, and that's all done, in this case, we're talking about subcritical, but also, as other people mentioned on this call, let's say you were doing a a topical batch and you wanted to run monosolvent CO2 supercritical to pull high fat and wax content, like you could still do that. So it has the ability to be run a number of different ways. But in this case, in this workflow, when we're talking about co-solvent and monosolvent terpene extraction, that's typically how the workflow looks.
Yep. Okay, so I think we're just coming up on time. If there are any other questions that anybody might have, please just drop them in the Q&A chat, and we'll get to them as soon as we can.
Hey guys, I'm going to jump back in here. We do have one, and then I'm going to ask another one, sort of paraphrasing a couple other questions, but we do have one here in the chat. Are there any significant challenges to receiving a stamped engineer's approval to the extraction equipment when combining CO2 with other solvents?
Yeah, that's a good question. I think we kind of sort of talked about it a little bit earlier, but it can be very geographically dependent. But we've put a lot of time and effort into making that process as painless as possible for our customers. The first thing as it relates to the pressure equipment itself is, does the equipment bear the stamps of the authority in the geography? In the US, it's generally ASME. In Canada, it's the CSA. In Europe, it's a PEDCE stamp. And there's a number of them that use either variations on those or their own all around the world. And so first things first is our equipment will be built and stamped and carry the documentation that shows that it's been built properly for the country of destination. So even though we're a Canadian manufacturer, we will build equipment to an American specification or a European specification, right down to the colors of the wires in the control panel. All those little things are taken care of and different depending on where the equipment is going. As it relates to the co-solvent module, the co-solvent module is completely shrouded and closed and pulled with a negative pressure, ventilated directly outdoors. And what we need to do is we need to maintain both a maximum amount of total solvent that can be in process at any given time to stay below NFPA limits, but also to satisfy the LFL limit, the lower flammability limit. So theoretically, if inside the box there was a valve or a fitting was to fail and start spraying ethanol all around the inside of the unit, we're evacuating enough air from inside the unit itself so that there isn't enough oxygen. Actually, less than 25% of the air required to become flammable is always being pulled, and that's interlocked to the function of the machine. So if the fan was to fail, the machine wouldn't operate. And that has been peer reviewed. We have a third-party peer review engineering report that's already been signed off on that we provide with the equipment. And so for your local inspector or your fire marshal, as I said, we've installed this in a number of states and Canadian provinces, and it's always there's always been a question or two because equipment like this hasn't really been designed this way before. So there's always like, oh, wait a minute, what did you design? Oh, that's actually really cool. That's that you made my job a lot easier. But yeah, we provide all that documentation with the equipment.
Fantastic. We do have a couple questions here that just came in from James out in the audience. I'll relay the first one here, but Jason and Nathan, you can both look at this as well. Is the ethanol extracted product dried in the system like a rotary evaporator?
So the extract comes out of the separators with the ethanol that was injected, homogenized in it. So that's where the ethanol comes out. The ethanol doesn't come out of some other separator somewhere or end up in the CO2 or in the accumulator. It actually comes out with the extract. And so if you were to proceed with an ethanolic-based winterization process, that homogenization step, you'd have a mixing crude with ethanol has already been accomplished. So that entire step has been avoided. And the fat content is incredibly low, like I mentioned before. It depends on variety, like the strain that you're extracting from, but generally in the 1% to 5% fat range. So there really isn't much winterization to do. It's usually in the freezer for a very, very short period of time. And we also have a completely automated skid that does all of that process for you. So you don't have like freezer and filter tables and so on and so forth. But if you were to do it in the traditional way, because I assume most of you on the Zoom today are familiar with that freezer filter solvent recovery step. The freezing process is very, very short because there's not that much fat and wax to precipitate. The filtration process is generally a single pass because there's so little to get. Because we're using just that right magic ratio of ethanol injection to pressure and temperature, we generally pull very little, if any, color. We have COAs to show that the process isn't pulling any residual sugar, which is a concern that a lot of people that are using ethanol in cannabis extraction have. So you can proceed straight to solvent recovery. But to kind of get to the question, do you recommend a thin film distillation? It will really depend, because we're doing such a good job of targeting cannabinoids and really not much of anything else. After you've gone through that winterization to de-wax and then you run solvent recovery, we're generally seeing most of our customers' extracts be at around the low 80% cannabinoid range already. So if you're distilling to hit a number, so say, for example, in the Canadian market, distillate really has a hard time selling on the Canadian market unless it's over 90% THC. So if you need to distill to get to that number, then that's fine. But if you're in a market where something that would be at 82 or 83 or 84% THC is a product that sells well and it's very flavorful and aromatic because we haven't run it through distillation, a lot of our customers have skipped distillation altogether because they don't need to hit a number and they're already making a number that sells well, if that answers that question.
Yeah, or if you're in a market that has a cap on THC percentage, which I happen to be in one of those odd places, Ohio, that has a cap, that you might have to actually dilute it, and before you go in, you would need to distill it to concentrate it any further.
Dilute it with the terpenes you extracted first and make it taste and smell good.
Excellent. I know James had one more question here about a brochure that covers these, costs, energy usage, solvent consumption, things like that. I might rephrase that a little bit as we're up against the hour here and ask, what can people do to either learn more or to get in touch, or perhaps to seek out a brochure that covers some of those statistics?
Yeah, if anyone has any questions after this webinar, please feel free to reach out to either us, Nathan or Jason. You can reach us at vitaliset.com. The product we've talked about today is the co-solvent injection system, which is designed as a modular solution to add to any of our existing equipment that we already have out in the field or in the fleet. So if any of our existing customers are listening, feel free to come and ask us about that. But our next generation of extractors are co-solvent integrated. So we have co-solvent and CO2 based refrigeration all combined into a single unit. So it really just requires instrument air and power. It rolls right through a standard door, plugs in, and we're usually making oil on the second day.
Fantastic. Well, this was a terrific conversation. Like I said at the top, wide-ranging and dynamic, covered a lot of topics. If anyone wants to get in touch, Jason just shared the information there, and we can certainly make connections after the webinar. But for now, at least, I want to thank everybody for attending out in the audience there. And of course, want to extend a thank you on behalf of the Cannabis Business Times team to Nathan, Jason, Mark, and John. Thanks so much, guys, for being here today and sharing all this information. It was great.
Thank you, everyone.
Thank you.